You are looking at a live view of SpaceX's Falcon 9 rocket as we prepare to launch the KF-2 mission from Space Launch Complex 40 at Cape Canaveral Space Force Station in Florida at 9:13 a.m. Eastern Time. My name is Tyler Lionquist, and I'm an analyst here at SpaceX. And welcome to our live launch coverage delivering 24 Kuiper satellites to orbit on behalf of our customer, Amazon. Today's mission is named KF-2 for the second Falcon 9 launch for Amazon's Project Kuiper. Project Kuiper is Amazon's low Earth orbit satellite constellation, which will provide fast, reliable internet to customers and communities around the world. Today's mission marks our second out of 3 planned Kuiper missions, and this will be the 4th launch of Project Kuiper satellites this year, adding another 24 satellites to its constellation. At just under T-9 minutes this morning, weather is still a watch item, but if we are unable to launch, a backup opportunity will be available tomorrow at 8:35 a.m. Eastern Time. And just a quick note, at our customer's request, we will be ending live coverage of the mission just after the first stage booster landing. As far as weather is concerned, we have been keeping an eye on our launch commit criteria all morning, and so far things seem to be working in our favor. But with that, let's take a moment to learn a bit more about the vehicle supporting today's mission. That's Falcon 9 on your screen. It is a 2-stage rocket that is 229 feet tall and is getting ready for liftoff in T-minus 8 minutes. At launch, it produces more than 1.7 million pounds of thrust, and rockets like Falcon 9 don't use all that power just to go straight up. Early in flight, Falcon 9 performs a gravity turn, a smooth pitch maneuver that tilts the rocket sideways to build up horizontal velocity. You might hear this call out about 10 seconds into launch as vehicle pitching downrange. Once the first stage completes its portion of the mission, it shuts down and separates. A staged rocket like Falcon 9 sheds the booster, so stage 2 and the payload can keep climbing faster and more efficiently. After stage separation, today's booster will land on our drone ship, a shortfall of Gravitas, which is currently stationed in the Atlantic Ocean. This particular booster will be returning to Earth for its first time. The second stage takes over from there, powered by a single Merlin vacuum engine, also known as the MVAC. With its extended nozzle and optimized design, the MVAC drives maximum performance in the vacuum of space.
Engine chill has started.
Topping it all off is the payload fairing, a 17-foot wide carbon composite shell that protects the satellite during the uphill trip through the atmosphere. About 3 minutes into flight, both halves of the fairing will separate and parachute back to Earth. Both fairing halves have seen multiple flights, one flying for its 28th time today and the other for its 5th. If recovery goes to plan, the fairings will be pulled from the ocean and prepped to fly again. So much of what makes Falcon 9 remarkable
Stage
happens.
1 RP1 load is complete.
Here's a good call. All happens in flight. The stage is separating, the first stage landing itself on a drone ship in the middle of the ocean, fairings parachuting back, all to get ready for another flight to space. At T-minus 6 minutes, Falcon 9 is tracking no issues and our payload is healthy. Falcon 9 has been loading propellant since T-minus 35 minutes and will finish loading at T-minus 2 minutes. And just as a reminder, if for any reason that we don't launch today, we do have a backup opportunity tomorrow at 8:35 a.m. Eastern. Now, next up in the countdown, the transporter erector, or the TE, will begin to retract away from Falcon 9. That is the large truss structure that you see standing next to the rocket. It's hinged at the base and is connected to the launch mount beneath the first stage. First, we'll see the clamp arms open around the second stage, and then the TE will begin to pivot back, slowly swinging away from the rocket. It'll reach its full recline by T-minus 3 minutes and 40 seconds. You might also hear the TE referred to as the strongback. It's the same structure, just a different name. And it does a lot more than just lean.
Falcon 9 tanks are pressing for strongback retract.
It rolls Falcon 9 out to the pad, raises it vertical and stays connected through to the final seconds to launch. It provides fuel, power, telemetry, and command connections between ground systems and the rocket. We're about 20 seconds away from starting to see those clamp arms opening up around the second stage on our vehicle stack. Those clamps help stabilize the second stage during fueling.
Strong back rechecks has started.
They also prevent movement in high winds. And once they're open, the rocket will be fully free at the top. You can see those clamp arms coming open now. It'll take about 15 seconds for them to fully open, but once they're out of the way, the strong back will recline away from the vehicle to give it room for liftoff. As you can see, those arms are open and the rocket is now free. You can see the strong back starting to slowly lean away from the rocket now. So right now, both stages are nearly fully loaded with about 1 million pounds of propellant. That includes RP-1, a highly refined kerosene, and liquid oxygen chilled to under 300 degrees below zero. Propellant is loaded late in the countdown, and that's intentional. Colder propellants are denser, and denser propellants mean more performance out of the same tanks. The colder it is, the more mass you can move. Before any of that propellant
Stage 1
flows
launch
up,
slot is complete.
and you just heard over the nets, there's confirmation of Stage 1 liquid oxygen loading completion. The second stage will finish up about a minute later. Before any of the propellant flows, though, the plumbing and engines are chilled down. That prevents thermal shock and boil off when the ultra-cold liquid starts moving. You might hear that referred to as engine chill. The tanks are also pressurized using helium. The helium is chilled too, so it stays compatible with the cryogenic plumbing. Then during flight, that pressurization helps force propellant into the engines as the tanks empty. At T-minus 60 seconds, Falcon 9 will enter startup, and at that point, the rocket's onboard flight computers will take over. From there on out, the countdown becomes fully autonomous. And then just inside of T-minus 2 seconds, the 9 Merlin 1D engines will ignite. Once they're at full power, Falcon 9 will lift off the pad and begin its climb to orbit.
All operators, this is Launch Director on Countdown 1. Just want to make everyone aware that we have a no-go condition on recovery weather. We will be standing down at T-minus 30 seconds. At 30 seconds, we will be calling hold. So stand by for that hold call, launch control.
Falcon 9 is in startup.
If you've been tuning into the webcast, you may have just heard that hold during the countdown. We will be going to T-minus 30 seconds and then holding there.
Hold, hold, hold.
Launch abort is running.
As you may have heard on the comms, we're standing down from today's launch attempt due to weather. The vehicle and the payload remain in good health, and our next launch opportunity is tomorrow at 8:35 a.m. Eastern Time. As always, thank you for watching, and we hope to see everyone back here for our next attempt.